So I'm making the table at the bottom because I can't fit. If you are making your table right next to the problem, that's fine. Remember, you have 2 tables to make, one for each equation. Thank you for that. Y equals 3x minus 5 is the first one. What about my second one? Now my table is going to be pretty much the same, so I'm going to copy it and paste it and move it where I want it to be. I just have to change the equation in a couple letters. And this is number 1. So I know which problem I'm talking about. This is going to be my red one. So I'm purposely making the equation the opposite color because remember, they're 2 different situations, and I want my work to stand out differently than my coordinates. But that's my choice. That's not necessarily what you have to do. The only thing you have to do is make sure you're blue or red only when you're doing your work in Kami. All right, what was my second equation, guys? Y equals x plus 3. Thank you. All right, so do I have fractions? Do either one of my equations have fractions? No. So if they don't have fractions, what are our numbers that we use? What are the numbers we use if we don't have fractions? We've done several tables. We should know what numbers we use every time. No. Give you a hint with the first one. What are the numbers that we use all the time when it's not a fraction? What would my next one be? Keep going. Two more. And yes, 2, 1, 0, -1, -2. That's when we don't have fractions. If we do have fractions that are in front of the x, then of course we have to do 2 times the bottom of the fraction, 1 times the bottom of the fraction. So we can do away with the fraction and still end up with 2, 1, 0, -1, -2. Now, I am using the same numbers for the other one, right? So I'm going to copy them. I'm going to change the color on them. Copy them. Paste it. And then I'm going to put the color back because I'm sneaky like that. Nope, ready to do wrong one. This one stays here and this one changes. Because I'm trying to color code. Okay, so someone tell me, what's my next step that I do? What piece of my equation am I going to use? I got a couple people who need to fix those cameras, please. What piece of the equation do I use? The whole equation? Or just part of it? Do we use the whole equation or just part of it? When I go down in here. The part of it. What part of it do we use? What part of this do we use? Okay, just the X piece, right? So I'm going to copy it and I'm going to paste it down here, right? And then I have to change what thing in it? What needs to change in it? Okay, and what are we changing the X to? The number that's on the left under the X, right? Now, are we going to do that same thing for all of them? Change that parentheses to the number that's on the left? Are we going to do the same thing for all of them? Change the number in parentheses to the number that's to the left? Yeah, so I'm going to copy and paste this down here because remember, work smart, not hard. This is where Cammie's nice. You don't have to write it all over again, over and over. You just get to copy and paste. But I understand some tech issues. Okay. And I'm going to go into the parentheses and I'm going to change it to the number that's to the left. This was a -2. This one says -1. This one says 0. This one says 1. Is everybody okay at that point? Everybody get what's going on? Okay. So now we're going to go do the math, right? Solve the math. So 3 times 2 is 3 times 2 is 6. So this would say 6 minus 5. And the answer we're going to put over here under the y. 6 minus 5 is how much? 1. Okay, let's go do the same thing for the next one. Solve the math. 3 times 1. Three, and it says minus 5. So what are we putting over here on the far side? Three, take 5 away. What would that be? Three, take 5 away. What would that be? -2. Yeah. Okay. So we say -2 for this one. Okay, next one. Do the math. What would we get? 3 times 0. 0. And we're going to say minus 5. So 0 minus 5, put our answer. Yep, -5. Okay. 3 times -1. -3. So that says -3 minus 5. Same sign. So we add them and keep the sign. What are we going to get? -8. Last one for this table. And then we have to go do the other table. 3 times -2. -6. And then it says to subtract 5 from that. So again, same sign, add them up and keep the sign. -11. Okay, so we're going to go get our coordinate pairs from this. We're going to go get our coordinate pairs from this. So I'm going to go down below and we're going to pull the pairs off in the parentheses, right? So our first one would be 2, 1. What would our next one be? Yes, 1, -2. Okay, make sure they're in parentheses, right? Because that tells us coordinate. What's our next one? 0, -5. Okay. Keep going. -1, -8. We're on our last one. What would that be? -2, -11. Right? Okay, so we're going to repeat the process for here. We copy the X piece down below. We change the X to what's the X on the left. And then we're going to copy that to the ones below because they're all doing the same thing. And we're going to fix them for what's on the left after we copy and paste them. Because this one should be a 1, and then a 0, and then a -1, and a -2. These ones are much nicer. We just get to go straight to the left column, right? There's no extra multiplying or anything like that. It's just whatever we picked for the X, and then add the Y in. So what's the first one going to say? 5. Okay, keep going. Someone else but Moses, come on. Come on, someone else but Moses. 3 minus 2, I don't think it's -2. Thank you, Brian, too. Remember, it says we're just going down 1 each time. Our change, it was a 1x, remember? That means it changes by 1 each time. Remember, the number in front of the X tells us how much it's changing by each time? The plus is where we began. So what's our last one going to say? 1. Okay. And we're going to get these coordinate pairs down below. What's our first one going to say? What's our first pair going to say? Yeah, 2, 5. Parentheses. Next one. 1, 4. 0, 3. Someone else. Yep, -1, 2. And then last one, -2, 1. Okay, we made our coordinate pairs. Are we all comfortable with making the table of value and doing the coordinate pairs? Other than doing it in Canny. You're comfortable with the process, right? So we're going to copy these lists up above. because this is going to be our work that we show here for the problem. And this one is supposed to be blue. And I forgot. And then we're going to copy the other list up above. If you did it right there, the lists are already there. It's not a big deal. Okay. So when we're looking at the points of intersection for the table, we have to look to see in what we've done so far, do we have where they're crossing? In what we've already finished doing, do we have where they're crossing? Do you see that each list has the same coordinate anywhere yet? They both have a 0, 3. They both have a -1, -8. Do we see that happening yet? Yes or no? Do we see that they have the same pair in both lists? Then you need to print out the paper like I talked at the beginning of notes to do. You have to do it on physical paper. Do we see anywhere that they have the exact identical pair on the lists we've already made? No. So we're going to have to expand the lists. We're going to have to expand the lists. But we're not going to redo more down below. We're just going to expand by using the pattern. We're going to do another one on either side and see if we get a pair. So let's do our first list. I'm going to have to change the size of this print down to be a 14 because we're going to have to add in some more. Okay, and the way we add in some more is we're going to do the next one we would have done if we'd gone bigger by using the pattern. Okay, how much is the first list changing by each time? Look in front of the X. How much is the first one changing by each time? 3. So if I'm going to go higher, I'm going to add 3 to the Y that was already there. So this would be a 3, 4. Because 1 plus 3 made 4. Okay, I'm going to add one more on this one. What is it going to be? How many is this one adding in each time? The second equation? I don't think so. What's in front of the X? That's what tells us how much is added in each time. That's our growth. 1. So that would be a 3 comma what? Not a 3, 5, but a 3. I add 1 each time. Three what? Follow the pattern of what happened with the Y. Follow the pattern of what happened with the Y. 3, 6. So I'm not doing the whole process of adding it to our table of values. We did the ones we need to do. Did we come to an answer where they both are crossing? Not yet. Are we getting closer? Well, let's look. When I was at -2, they were 10 apart from each other, right? When I was at -1, they were only 6 apart from each other. When I was at 0, they were 2 apart from each other, right? So it looks like how far apart they are is getting smaller and smaller. That means they're coming to a crossing. So do we think that they're going to be coming to a crossing at the negative side, -3, or the positive side, +4? Which way do we think they're going to come to a crossing? Is it getting smaller as I get bigger with my x's? Or does it get smaller when I get smaller with my x's? As my x is getting bigger, my distance between the points is getting smaller, right? Okay, so we're going to go bigger because the distance between is getting smaller. We're going to do the 4. What would the 4 be? Remember, we're adding 3 to the y each time, 4, 7. Okay, now we're doing the second one. What would its 4 be? What do you know? 4, 7. Did we find our answer? Yes. Now, sometimes you're going to have to add more in at the negative direction because you notice they're getting closer together as the next x's get smaller. Sometimes you're going to have to add in on the x getting bigger side because you notice the distances between the y's are getting closer as you go positive. Okay, I'm only expecting the table of values for the 2, 1, 0, negative 1, negative 2. You get to use the pattern for the add-ons. Okay, so we see that their point of intersection, no, not what I want to know under the circle. Their point of intersection is 4, 7. Okay, so we're going to repeat that process for the number 2. So we're going to have to go copy the tables, fix them for the number 2 equations, repeat the process. Okay, so I'm going to go down on my page. I did the wrong thing. I'm going to go ahead and zoom out a second to see how much space I still have. And for me, I don't have much because I write big. So I'm going to just add another page for my page 2. Do you have to add another page? No. If you have space, go ahead and do them on the same page. If you did your 2 tables side by side, obviously you would have space. It is up to you how to show your table work. If you're writing small enough to fit it right with question 1, fine. You still have to make the list and circle in the list though. Okay? So I added another page in. I'm going to do the same process I did for number 1. So I'm going to copy that over and just adjust it for the new equations. And just adjust it for the new equations. It's okay. That's the feature of Cami. That's nice. The copy and paste. This is obviously question 2 now. I need to change the equation to the correct one for question 2. What's the first equation for question 2? So as much as possible in Cami, I'm trying to use what I already have and just adjust it as I need it. Okay. So I need this 2x part, right? Because I'm trying to use what I already have, work smart, not hard. Obviously, if you're on the paper itself, then you have to go write it. But we can copy and paste because we're virtual. Right? Same process we just got done with. We just changed up the numbers a little bit, right? All right, so we changed up the numbers. We have to solve the 2 times 2 thing. Let's second ago. We're doing the math part now. We got done with the copy and pasting part. 2 times 2. Two times 2. Solving the math part. What's 2 times 2, guys? 4. So this says 4 plus 16. What would I have over on the side if it's 4 plus 16? What do I get? 20. So all I'm doing is changing the numbers to match the new equation, but the format's not different. Okay, so what's my next one going to say? Two times 1. 2 plus 16. Thank you. So the final answer is going to say 18. Someone other than Brian take over. What's it going to say? What's it going to say? 2 times 0. So this is going to say 0 plus 16. And on the far left, it's just going to say 16, right? Okay. What's the next one going to say? What's our next one going to say? Yep, -2 plus 16. So we get an answer of 14. And that makes sense because it says the growth is 2 each time, right? So far our growth is matching. Okay, someone other than Brian. What's the next one going to say? -4 plus 16. So what are we going to get? Remember, we subtract and keep the sign that's on the bigger one. 12. Okay, now we're going to go make our coordinates. The 2 was 20. What was the 1? So we're just going and changing the y side, the y part, to match the 0. -1. 14, and then -2, 12. Okay, we good so far? So we have to repeat for the second equation. So I need that second equation, please. What's the second equation from number 2? Okay, 5x plus 4. Okay, so I'm going to copy down this 5x plus 4 part. I'm going to change the X to the X value that's just to the left. And then I'm going to copy these instructions to each of the ones below it. Because I'm working smart, not hard, I might as well do my copy and paste the computer program lets me do, right? Obviously, if you're handwriting it, you're going to handwrite it the right way the first time and not have to go back and change it. But we're just copying and pasting. That's a -2. This says -1, 0, and 1. Now, just like we did above, we have to go do the math. Just like we did above, we got to go do the math. So, what are we going to say? Calculate the 5 times 2. What are we going to get? What's it going to do? The math for me, guys. Yep. 10 plus 4 for an answer of 14. Okay, next. 5 plus 4 for an answer of 9. Next one. Zero plus 4 for an answer of 4. Okay. Next one. What's our next one? 5 plus -1, what would we get? What's 5 times a -1? Do the math. 5 times -1. -5 plus 4. So what is the answer over here going to be? They're not the same sign, so we got to subtract and keep the sign that's on the bigger one. So what's it going to say? -1. Exactly. Okay, do the math for the last one. What's it going to say? Five times -2. 5 times -2. Got to show the math. -10 plus 4. So -6. You cannot use a pattern to fill in the table of values. You have to show your work. Okay. I know at a certain point we start seeing the pattern and want to just go with the pattern, but you've got to show your work. Okay. We've got to go change up our numbers here. First one was 14. Second one said 9. Third one said 4. Then -1. And then -6, right? Okay, let's go copy our lists to up above. This is number 2. I did it again. I forgot to change it to the Okay, do we see the same number on the table, on the list we already have? Did we find the same number yet? Did we find the same number yet? No. So we have to go ahead and we have to extend our list using the pattern, either going up for the X or going down for the X. So we have to look at what's happening. As our X's get bigger and bigger, is the space between the Y's getting smaller or larger? So at -2, a small X, we were -6 and +12. How much distance is between -6 and +12? How much distance is between -6 and +12? If I'm on a number line and I start at -6 and I move all the way to +12, how far did I go? 18. Okay. Do the next one. -1 to +14. How far did we go? Okay, so is our distance getting bigger or smaller? Smaller. So that means as the X's are getting bigger, the lines are coming together to make their intersection. So we're going to use positive numbers and the pattern to stretch our list, just like we did for number 1. We're going to stretch our lists just like we did in number 1. Okay, we're going to figure out what would happen if it was 3. So it says we're adding 2 each time. So 3 comma, what would the Y be? If we're adding, yeah, 322. Okay, now we're going to go do the X. Now we're going to do the other one. 3 comma 4. 14 plus 5 is 21. Because remember, you add 5 each time. That's what's in front of that X. Yeah. Okay, did we find the pair yet? No. So we got to go do it again. We got to extend our list to the 4. Using the pattern, what would the Y be? For the first equation, it says add 2 to the Y each time, because that's the number in front of the X, right? So if I was 4 with the X, what would the Y be? Follow the pattern to get the Y. 24. Okay. Now we've got to go stretch this one. 4 comma, this one has a 5 in front of the X, so I'm adding 5 to the Y each time. Yay, we found it. Again, using the pattern after we did 2, 1, 0, -1, -2 on our table, okay? I'm not expecting you to extend your table past the 2, 1, 0, -1, -2. You get to use the pattern, okay? Are we okay? Questions about what's happening yet? Because we have one more set to go do with tables. And then we notice that they want us to do graphing as well. For numbers 5 and 6, we're going to be graphing. Okay. So are both of these equations in the right format? Are both of those equations in the right format? No, which one's not in the right format? First one, how can we rewrite it in the right format? Because we want the right format. So we need to rearrange it so it's y equals mx plus b, correct? So how would we rewrite this? What would we say? Y equals what? Yes, negative 3x, positive 7. Because we know nothing in front of a number means positive, right? Okay, so we've got our equation for this one. Okay, I'm going to go get my tables made. I prefer a page card. You don't have to. Remember, we've already talked about that. Can I fit both of these on another page? I don't feel comfortable with it. So I'll just make a new page. Does it matter? No. As long as they're there. Okay, as long as they're there. Okay, I'm going to copy my formatting because I want to work smart, not hard, right? Select. This is what I want to use again. I'm going to copy it. I'm going to move and I'm going to paste. And then you shift it before doing anything to it. Okay. All right, text box for you. That's your number 3. And then I'm going to zoom in again. Okay. So what was my first equation we just said? Negative 3x plus 7, right? So I'm going to take that negative 3x and come down below with it. Change the x to the x that's just to the left and take the x out. And then copy that work style to the other ones, right? And by the way, the copy and paste features are the same as they always are. Control C and Control V once you highlight it. So you don't have to do anything new to learn it. Cami didn't make anything extra on that one. And then I go change my bubbles so they match the X that's to the left. And I go solve the work. What's the first one going to say? What's my first one going to say? What's my math, guys? That says negative 3 times 2. What would that be? Negative 3 times 2. What would that be? Someone tell me what negative 3 times 2 is, please. Okay, so this says negative 6 plus 7. What would happen if we do that? Subtract and keep the sign on the bigger one. They're not the same sign. So negative 6 plus 7 would be what? 1. Okay. Do the next one. What's the math going to say? 3 times negative 1. -3 plus 7. Not the same sign, so what would we get? Subtract and keep the sign of the bigger one. Yep. Okay, next one. Zero plus 7. Easy. 7. We like the zeros because they're kind of easy. How about the next one? -3 times -1. What's going to happen? +3 plus 7. What are we going to have then? 10. Someone other than Delilah, come on. -3 times -2. What are we going to have? 6 plus 7. So what's our answer going to say? What is 6 plus 7? 13. Okay, so that one's done. We just have to adjust our list, right? When it was 2, it was 1. When it was 1, it was 4. When it was 0, 7. Now, this makes sense because it says we're going down by 3 each time. We're going down by 3 each time. So as my x's get bigger, my y's are getting smaller because I'm going down by 3 each time because the number in front of the x says -3. Okay. What is my second equation though from up above for number 3? What's my second equation from up above for number 3? Thank you. 2x minus 8. Okay, so we're going to copy that 2x minus 8 part down below. Fix the x to be the x that's to the left. Copy and paste, right? Stop it. Sometimes the computer program argues. All right. Last one, and then I have to go change the x numbers to what's to the left. So this one says -2. This one says -1, 0, 1, and we already had the 2. Okay, now we just go do the math. So someone tell me the math for the first one. What's it going to be? Four minus 8. Thank you. And its answer would then be what? Not the same sign, so subtract and keep the sign that's on the bigger number. Subtract and keep the sign that's on the bigger number. What are we going to say? Exactly. Nice. -4. Okay. What's the work for our next one going to say? Two take away 8. Okay. If I take 2 away from 8, what am I going to be? And what's the sign going to be? -6. Okay. How about the next one? What are we going to say? Someone other than Mercedes, help out. Someone else other than Mercedes, tell me what the answer is going to be. Nice work, Mercedes. So what are we going to get? 0, take 8 away. -8. Okay. What's my next math going to say? -2 minus 8, which gets me what? -2. Last one. What's it going to say? -4 minus 8, same sign, add them up, keep the sign. What are we going to get? -12. And then I'm going to go fix my list to show the same numbers. That was a -4. This one said -6. This one said -8. And this makes sense because the number in front of the x says +2. So each time the x goes up, the y is going up by 2. Okay, and we copy our lists up above, right? This is my red one. Here's my blue. I remember to change the color this time. Okay. Did we end up on our list? Oops. Right idea, wrong thing. What happened? I didn't copy the correct list. Look at that. Okay. I was all excited. And then I realized I didn't copy the right list. Okay, there's our 2 lists, right? Okay, so we're going to look at it. Which direction is the x going that makes the numbers come closer and closer together? Okay, so for -2, I have +13, -25. So if I 12. So if I started at -12 and I went all the way to +13, how many spaces would that be? If I went from -12 all the way to +13, how far on the number line would we go? So if we start at the +12 on the number line and we count all the way to spaces until +13, how many spaces would we have counted? How many spaces would we have counted if we started at -12 and moved all the way to +13? How many spaces is that? Come on, guys. How many spaces is that? Think about it. If I start at -12, I've got to go -12 to 0, and then 0 all the way to 13. So how far did we go? We started at -12 and ended at +13. How many jumps on the number line is that? If we start at -12, go all the way to +13, how far apart is that on the number line? Because I think that's 12 jumps to 0 and 13 jumps out of 0. I don't think that's the number 14 If you're starting all the way at negative 12 and going all the way to positive 13, how far is it? $25. Okay, so then let's look at the negative 1. Starting at negative 10, going all the way to positive 10. How far? How far is that? Starting at negative 10 and going all the way to positive 10. How many jumps on the number line is that? Come on. We start at positive. If we start at negative 10, jump to 0, that's 10, and then jump to positive 10, that's another 10. So how far apart? 20. Did we get bigger or smaller in our apart? If I started at 25 apart and I'm now 20 apart, was that bigger or smaller? That was smaller. So that means as my x's are getting bigger, my lines are coming closer and closer together. Okay. If the space was getting bigger as my x's were getting smaller, I would know I'd have to add on to the negative end. Okay. But since the numbers are getting smaller as I go bigger and bigger for my x, I get to add on to the positive end of the x. Okay, so we're going to add on our 3. What would our 3 be for the first one? 3 comma what? Says subtract 3 from the x, from the y each time. So 3 comma what? Negative 2, because 1 minus 3, negative 2. Okay. This one says add 2 to the y each time. So 3 comma what? Started at negative 4 and I'm adding 2 to it, negative 2. Yay, we only had to go 1 extra. But we might have to go 2 sometimes. And it might have to be on the negative side sometimes. And it depends on, is the space between the 2 y's for negative 2 and then the 2 y's for negative 1, did the space get bigger? Then we have to add towards the negative end of our list. Did the space get smaller? We add to the positive end of the list. And we're adding to the list by just using the pattern of what's happening with the y's. Okay? There's my answer. I don't like where it ended up. Okay. So you're always on your table of values doing 2, 1, 0, negative 1, negative 2. I'm not making you do more than that on your table of values. If your answer isn't on the table of values when you bring the lists up, then you just use the pattern to add to the positive side of x's. If my space between the y's is getting smaller as I move to bigger x's, I'm going to add to the positive side of the x of the list. If my space between the y's is getting bigger as I go positive, then I have to add to the negative side. Okay. So we did, now we're on 4. And 4 is where? Where's number 4? There wasn't one on the worksheet. I don't know why. Okay, so now we're looking at 5. We're looking at 5. They want us to do this by graphing. In order to graph, we need to go ahead. And we're going to use our shortcut trick to graph. Are both of the equations in the right format? Are both of the equations in the right format for number 5? No. Which one's not in the right format? I'm gonna make the top one the blue, and the bottom one's gonna be my red. So the bottom one is not in the right format, the red one. So I need to fix it so it is the right format. I need to fix it so it is the right format. What is the right way to write it? What should they have written it like? Yeah, y equals mx plus b, so that should be y equals negative x plus 12. Okay, so we're going to do the shortcut method. Ready? We already did it once before. For each equation, we're going to figure out the m and the b, and we're going to use those to help us. So for my blue equation, I need to know the m. Where do we find the m? It's the number in front of the x. If we do not see a number, what is it? When we do not see a number, what number do we use? Because remember, the m is in front of the x. I don't see a number in front of my x, so I know it's the number what? What number did it have to be? Yes, it's 1. Because remember, 1 times something, we don't write the 1 times something, we just know it's there. Okay, now we need the b for this one. And we need the b as a number, and we need a b as a coordinate. We need both. So what is our b for this first equation? Grab it from the equation. What's the b? Remember, because our format goes y equals mx plus b, right? Right? That's our format that we're looking for. So what is the b for the first equation going to be? The number at the back of the first equation is what? Because b is what's tacked on, yeah, negative 6. So what is that as a coordinate, though? What is that as a coordinate, though? What would my beginning point be? What is the x value all the time? Yes, 0, comma, negative 6. I think you were saying the 0 a little bit too, Brian. Okay, with that in mind, we have to go do the second one, okay? What is the m for the second equation? Think about it careful. What is the m for the second equation? Almost. What's in front of the x? Yes, negative 1. Because I don't see a number, I just see a negative sign. So that must mean it was times by 1, but it was times by negative 1. Nice catch. Okay, what's my b for the second one? As a number and a coordinate. 12, and that would be a 0, comma 12. Okay. Are we okay with that? We understand where that stuff came from? Now we have to fit this on our graph, right? We have to fit this on our graph. How many lines for the x direction do we have to work with? How many lines do we have? How many lines do we have? Count them. How many lines do we have? Count them. $10. Okay, how many lines up do we have? How many lines up do we have? 1, 2, 3. Count how many lines up we have. If I start right here, 1, 2, 3, 4, how many blue? We have 10, but we need to be able to go up to what? 12. So are we going to be able to use ones going up and down? No, we have to use what? We have to use twos. Okay. So no, I don't want it too big. I want it, let me see if I can. No. Nope, it won't let me go to 140. I want the one in between. Okay. So we're going to have to go by twos, up and down. So each line, 2, 4, right? What am I going to say when I get to the top? Oh, I know what I am. That's fine. I was wondering why it wasn't working. It's because it was a circle, not a line. Ooh. What are we going to say at the top if we're going by twos? What are we going to go say at the top when we go by twos? 20. Okay. Go down. What is it going to say? We're still going by twos. Negative 20. Yep. So this is the Y. Oops, I have to be on. And that's a positive 20. And when we go do our line down, we're going to be going to negative 20. Now, if we're going our X direction, do I need to go by 2, 1, 0, negative 1? I mean, my X's go 2, 1, 0, negative 1, negative 2, right? So am I going to need to go by more than ones going sideways? Am I going to have to go by twos sideways also? If the X's I'm looking, yeah, no, we don't. So we get to go by ones. We get to go by ones. Okay, here's our shortcut, ready? We'll get to that side in a minute. We're going to take our beginning. Okay, take our beginning. I'm looking at the blue one first. Our beginning says 0, negative 6, right? So 2, 4, 6, right? 0, negative 6. Yes? And it said that I'm supposed to go slow. My movement, my slope is supposed to be 1, but I thought our growth was supposed to be a fraction. So how would I change this 1 into a fraction? What can I do to change that 1 into a fraction? A 1 over 1. That means, since it's a positive 1, that each time we jump, we're going to be going up 1, right 1, because they're both positives from our beginning, okay? From our beginning. So I'm going to put my beginning back. And I'm going to go up. How many spaces are we going, though? If I go up, each line is worth how much? If I go up, each line is worth what? 2. So I'm not going up by 1. I'm going up by 2 with each line. So if I have to keep the balance, if I have to keep the balance between it, so it ends up still equaling the number 1, I want to still equal the number 1. How much do I have to go over then so that I get the answer of 1? I'm going up by 2, and I need to divide by something, so I keep that equaling to 1. 2 divided by what makes 1? 2 divided by what makes 1? 2 divided by what makes 1? Come on, guys. 2 divided by what makes the number 1? 2. So since my y's have to go by 2's, my x's have to go by 2. So let me finish this dot so you know how to finish your worksheet before the end of lunch. So I'm at my beginning spot, right? I'm at this 0, -6. And I'm going up 2, and I'm going over 2, because I want the relationship to still equal 1. And then I would go up a 2, and I'd go over a 2. So I keep the relationship of moving, growth, still equal to 1. And I would connect them. So because the y's had to go up by 2's, the x's had to go up by 2's also. Okay? And you would put coordinates on here. And you would repeat it for the second one. And I will have Zoom open at late lunch if you want to come in and get some help. Okay? But I am expecting that by the end of late lunch, 5 and 6 will be finished. Okay? Have a good day.